Our last section of Chapter 8 is called the Law of Cosines, and it's similar in use to what we did in Section 5, the Law of Sines, in that it can be used when we're working with triangles that are not right triangles. So unlike the rest of our chapter where we looked at right triangles, Pythagorean theorem, SOHCAHTOA, we used those two things to find side lengths and angle measures. In right triangles, Law of Cosines can be used to find side lengths and angle measures when we don't have a right triangle. Now, we looked at in Section 5 at Law of Sines, and we said, hey, we can use that when we know an angle measure and the length of the side that's across from it. Or if we could find that angle, let's say we had the other two and we could use triangle sum. Now, today we're going to look at Law of Cosines, and that deals with when we have a triangle with SIS, meaning we know side, angle, side, two sides, and the included angle, or all three sides. If you look at this key concept box here, it has listed here 3 formulas for the law of cosine. But really what's important here is just that notice our labeling of our triangle, much like we talked about with law of sines, where our capital letters correspond to our vertices and they're crossed from the corresponding lowercase letter opposite it. That's the key part. An angle and its opposite side are the same letter. And that's what we see as being the most important here with our law of cosines, is that my side I'm looking for, or the side on the outside of the equal sign, is corresponding to the opposite angle inside that cosine. So we're only going to use angles here in one position, or we're going to be finding an angle using this formula. And whatever side we're looking for, or the side we know on the outside of the equal sign, needs to correspond to the opposite angle. Notice everything else here, the B and the C are lowercase, they're corresponding to the other two sides. So that's kind of a lot to take in just looking at the formula. Let's go ahead and try to put it into play, and hopefully it will unfold and make a little more sense for you here. So we've got a triangle ABC here. We're asked to find B, lowercase b, to the nearest tenth. That's referring to this side AC. Now remember, lowercase b is going to be across from the capital letter B, and that's the angle. Now, we know we need to use law of cosines here because I know a side, an angle, and a side. I can't use law of sines because I don't have any angle and the opposite side known. Okay. Typically, if you can use law of sines, it's going to be a little bit quicker process. That would be what I would recommend. But if you can't use law of sines, you need to use law of cosines. You need to make sure you know how to set it up. So in this case, if I'm looking for B, you can think of this two ways. You can go ahead and look at your key concepts equations here and take the second one, or you can really just remember that this side, lowercase b squared, is going to be on the outside of the equal sign, since I know the opposite angle. So let's just go ahead and jot down that formula that we have. The side length b squared is equal to the side length a squared plus c squared minus 2 times a times c times cosine of that angle opposite the side we're looking for, cosine of capital B. Okay. Now let's go ahead and identify what our variables are. Lowercase a, we said, is always across from capital A. So lowercase a has a length of 22. Lowercase c is going to be across from capital C. That's going to be our side length 10 here. Capital B, any capital letter refers to our angles. Capital B is going to be 44 degrees. Now, the next step is really just a plug and chug process. I don't know lowercase b, that's what I'm looking for. So lowercase b squared equals a is 22 squared plus c is 10 squared, minus 2 times a is 22, c is 10, times cosine of capital B is 44. Now notice, that's just one big long string of numbers being added, subtracted, multiplied, trig. All of that's going on, but there's nothing you have to really do a lot of solving for here. So I'm going to go ahead and put all of this in my calculator, and I'm going to show you how I do it. But be aware that you may be better off not putting it in all at once and kind of doing it step by step. If you're not getting the same thing I'm getting, then you may need to break it down step by step. And just make sure that you are very clear with your values. If you get sloppy, you're going to likely make a mistake because, like I said, there's kind of a lot going on here. So I'm going to do it all in once. Your calculator might look a little bit different than mine, might work a little bit differently than mine, so you'll have to use your own discretion at whether you can put it in at once or not. So I've got 22 squared plus 10 squared minus 2 times 22 times 10 times, and remember I put my 44 first, then I select cosine, and then I need to select enter. So that tells me b squared is about equal to 267.49. If you didn't get that number when you plugged it all at once, go back, pause the video, try again, break it down, whatever you need to do till you get that number correct. Now, I don't care about b squared, though. I don't care about the side length squared. I care about what just b is. So to get b by itself, I'm going to square root both sides. And if you can in your calculator, the way I can in my calculator, leave this from the previous time I hit enter from finding that long expression, and then just go ahead and click the square root, and it's going to automatically keep that number. And then you don't have to retype something long and nasty, or you don't have to do as much rounding. So it tells us to round to the nearest tenth. So b is approximately 16.4 units long. Again, if you did not get that when you practiced it on your calculator, pause the video, go back, do it again until you're getting those numbers, because if you're not getting the right numbers now, you're probably making a mistake. It might be with putting in your trig function wrong. It might be with putting in all the expression at once wrong. Just keep doing it till you figure out what your error is. If you can't figure out your error, email me. So let's try another one like that. When we're looking for a side length, it's really just a game of plug and chug. So here we've got a different triangle, triangle LMN, and I'm asked to find length MN to the nearest tenth. So you can kind of go about this however you feel most prepared. If you want to, you could label your side lengths with the lowercase letters and replace A, B, and C with M, N, and L. I'm going to, just for the sake of continuity here, I'm going to go ahead and just relabel this triangle using capital A, B, and C for my vertices, and then the lowercase letters. Now, you don't have to do that, and I'm not going to do that every time, but I'm just going to do that now to kind of help show how they're related, which makes, and you can put your A, B, and C in any order. I'm going to pick them in this order, making the side I'm looking for lowercase a, 48 is lowercase c, and 29 is lowercase b. So in this case, if I'm looking for the side BC or MN or lowercase a, however you want to call that, I know I'm going to be using that 104 with my cosine. So that tells me that a squared is going to be equal to my other two sides squared and added together minus 2 times BC times cosine of capital A. And once we identify those variables, we kind of already did. We said lowercase b is 29, lowercase c is 48, and capital A is 104. Again, it just becomes plug and chug. Just be very careful that you're not forgetting any of those parts of the expression. So a squared equals 29 squared plus 48 squared minus 2 times 29 times 48 times cosine of 104. Again, practice this as we go. Make sure you're getting the same thing I am, and that you're able to do those trig functions correctly. So again, let's go ahead and plug this into our calculator. 29 squared plus 48 squared minus 2 times 28 times 48. Oh, 29. I made a mistake. With a mistake like that, I'm just going to have to clear the whole thing and try again. 29 squared plus 48 squared minus 2 times 29 times 48 times cosine of 104. And then don't forget to click enter. And we should get 3,818.51. Now remember, that's what a squared is equal to. And that's an approximation since we have to round. 3,818.51. So to get a by itself, we're going to need to square root both sides. And again, since we're talking about length, we really only care about the positive value. If you've got that previous computation still in your calculator, you can just go ahead and click the square root button. And a is approximately 61.8 units long. If you've tried and you cannot get those values to match what mine are, couple things. Make sure that you're in degrees and not radians. With my calculator, it's this purple button here. If you're using the Google Scientific Calculator, slide that tool at the top left-hand corner to make sure degrees is showing, not radians. If you're using a handheld, find mode on your calculator. Make sure that DEG is highlighted and not RAD. If that doesn't work, just let me know and I'd be happy to go over that with you. All right, so those two examples were pretty straightforward. They were, hey, let's take the side angle side and let's find the missing side length. Now, it's a little bit more challenging when we have to find a missing angle. mostly just in that you're following your order of operations correctly. The process is lengthy, but it's not really hard. Just make sure that you are not doing any any operations out of order. So let's go ahead and try that, and I'll show you what I mean here. So I've got triangle XYZ here. Notice I know all three side lengths. So I got a 4, a 6, and a 7. And I'm asked to find the measure of angle X to the nearest tenth. So since I'm looking for angle X, I'm going to use this side 7 as my outside value. So it's going to be 7 squared equals. So in this case, I'm going to 7 squared equals my other two sides squared and added together, 4 squared plus 6 squared, minus 2 times 4 times 6, and this is just still using that same formula, times cosine of the angle I'm looking for. And I don't know it. Unlike those last two examples, I don't know that angle measure, so that's just going to be capital letter X. That's what I need to solve for. And what's really the most important when you're setting this up is that the angle that goes here is across from the side length you have here. X across from 7 squared. Now, when you're doing this, when you're using law of cosines to solve for an angle, I see this happen all the time. Kids get it wrong because they rush, they don't follow the correct order of operations. Give yourself a third to half a page of paper to write this out, find every single value in between. Don't take shortcuts, because when you take shortcuts is when you make mistakes. So I'm just going to start by multiplying out and squaring what I know. So 7 squared is 49, equal to 4 squared is 16, plus 6 squared is 36, minus, now I can multiply these together. That's a legal thing. I've got 2 times 4 times 6 times cosine of X. 2 times 4 is 8 times 6 is 48, and then my variable is inside that cosine. It's just going to stay there for now. Now, I'm going to tell you right now what the most commonly made mistake is that's going to get you the wrong answer. People want to do this, 16 plus 36 minus 48. We cannot do that. This right here is a chunk. That's going to be the last thing we deal with. So if you need to, put a box around it, circle it, highlight it, underline it. Don't touch it till the end. Let's get rid of that 16 and 36 first. I can add those together. So if I add them, I get 49 is equal to 52 minus 48 cosine of X. Again, don't do 52 minus 48. This is a multiplication here. That needs to be dealt with after we get rid of any addition or subtraction. So now I'm going to subtract 52 from both sides. Remember, I'm working to getting that X by itself. 49 minus 52 is negative 3, equal to, don't drop your negative, 48 cosine of X. Now, this should look kind of like what we saw with SOHCAHTOA. We need to get that X by itself. So the first thing I'm going to do here is I'm going to divide both sides by negative 48. And it's going to give me a nasty decimal, but that's okay. Negative divided by negative is going to be positive, so I'm just going to take 3 divided by 48. 0.0625. Oh, this one wasn't even nasty. This isn't, that's a doable number. Is equal to, now this is not what X is equal to. This is what cosine of X is equal to. I don't care about cosine of X. I want to know what that actual X value is. So if you remember, again, think back to when we worked with SOHCAHTOA, to undo a trig function, we use the inverse trig function. So in order to get X by itself, I need to take the inverse cosine of 0.0625. That's how I isolate the X. That's how I undo cosine. And again, in your calculator, if you leave that division that you had from the previous step, find your inverse functions. In my case, it's the up arrow. If you're using the Google calculator, it's INV. If you're using a handheld, you have to click second and then cosine. Inverse cosine of 0.0625 is about 86.4 degrees. And that's my final answer. Okay. Now, a little bit lengthier process, but as long as you're following that order of operations, as long as you're working the correct steps at the correct time, it should be doable. If you need to just rewatch this or write down all your work as you go, as you hit the homework problems. Now, using law of cosines, I could find any angle inside of this triangle. You would just switch around which side length you put on the outside and which two you put on the inside. So let's look at one more example like that. It says in triangle TUV, TU is equal to 4.4, UV is equal to 7.1, and TV is equal to 6.7. Find the measure of angle V to the nearest tenth of a degree. Now, this one's going to be the exact same thing we just did in the last one. The only difference being, since I'm working with values that have a decimal point, it's going to be a little bit nastier numbers. So as always, start by drawing a picture. It doesn't matter if it's accurate or not, or drawn to scale, but just get yourself a picture so you know what you're looking for. Now I'm asked to find the measure of angle V. V is this angle here, and that means that I'm going to use the side across from it, TU, or that 4.4, on the outside of my equal sign. So let's start by setting that up. 4.4 squared equals my other two sides squared and added together, and you can put those in either order. It doesn't matter if you do the 7.1 first or the 6.7. Minus 2 times 7.1 times 6.7. And you know what, I'm too high here. Let me just move this down a second so I don't run into my triangle. 7.1 times 6.7 times cosine of, and now again, I don't know that value. That's what I need to find, so that's going to stay my variable. And go ahead and keep simplifying. 4.4 squared is 19.36. I've done these ahead of time, so if you're using a calculator, you can double check as you go. I'm not doing these in my head, but just to save some time. We can multiply these together. 2 times 7.1 times 6.7 is 95.14 cosine of V. Again, we're working to isolate this V, so I need to get rid of everything else to move backwards to get that V by itself. So I can add the 50.41 plus 44.89, but this is what we need to box off. This is what we're not going to touch till the end. So if we add those together, we get 95.3. We've got then minus 95.14 times cosine of V, all equal to 19.36. Now to undo that, we're going to subtract it from both sides. So minus 95.3 and minus 95.3. And we get negative 75.94 is equal to, again, don't drop that negative, negative 95.14 cosine of V. And now I can deal with this 95.14 by dividing both sides by negative 95.14. And here we're not going to get a nice number, and I can throw that in here. Negative divided by negative is going to be positive. So 75.94 divided by 95.14, about 0.798. Leave that in your calculator if you can to use that in our next step. So I've got 0.798 is equal to cosine of V. Now how do I get V by itself? Remember the process. To undo a trig function, we need to use inverse trig functions. So inverse cosine of 0.798, oops, and I missed my 9 in there, is going to give me my value of V, which tells us V is approximately, now, just like the last time, if you can leave that number on your screen and just click inverse cosine, it's going to give you a more exact number, about 37.0, if you want to round to the nearest tenth, degrees. So when you're looking for an angle measure, just take your time. Write it all out. Do not, this is the cardinal mistake, and I'm telling you how many people do it all the time, do not try to add and then subtract. That will give you the wrong answer. Add these, then start solving for V. If you have any questions or if you're not getting the same thing I am, please just shoot me an email. Good luck.